Hello friends. So another video on consolidation of soil. This is the problem of 2021 set 2 and this is quite a standard problem. A large embankment. So you are being shown the embankment load here. So a large embankment is to be constructed. Calculate the primary consolidation settlement of clay. So over this ground surface or ground level, you are going to construct an embankment. So you will have to calculate the primary consolidation settlement. You have been given that the effective overburden pressure plus the increase in pressure due to application of this embankment load is given to you as 180 kilopascal at the middle of the clay layer. So how to find out the consolidation settlement? Here, if you look to this problem, this is the ground surface, this is the embankment load, and up to 2 meter, it is a sandy bed, and the value of unit weight is given to you. The groundwater table begins over here at 2 meter from the ground level and followed by clay. So clay is going to have the properties specific gravity 2.65 and the thickness of the clay layer is 8 meter as shown in the figure. The moisture content is given to you as 45% and gamma W is also given to you as 9.81 kilonewton per cubic meter, and the compression index is CC is given as 0.25, and below the clay layer it is impermeable layer. So this problem, this figure is given in the problem, and therefore we need to find out. So let's see the solution of this problem. Here we want to find out the consolidation settlement. Primary consolidation settlement is given by Cc divided by 1 plus E naught into the thickness of the clay stratum H into log of sigma naught prime, that is the effective overburden pressure, plus due to loading, what is the increase in pressure at the middle of the clay layer divided by sigma naught prime at the middle of the clay layer. So effective overburden pressure to the base 10. So this is the formula for primary consolidation settlement. So we need to find out SC of the given clay, and the formula is known to us. So here what is given is due to loading, the total effective overburden pressure at the midpoint at the middle of the clay layer, which is of 8 meter. So that's given as 180. But you need to find out the overburden pressure, effective overburden pressure at the middle of clay layer. So this, therefore, sigma naught prime needs to be calculated at the midpoint. So at the middle, what is the first 2 meter, the unit weight? So Z multiplied by gamma or 2 meter, we can directly write that up to 2 meter, z equal to 2 meter, and the above the groundwater table, whatever is the total unit weight, uh, that has to be taken, plus if you go to the middle of the clay layer, the total distance is going to be 4 meter multiplied by the effective unit or submerged unit weight of the soil, clay soil mass. Now, what is the submerged unit weight of the clay soil mass? Because you know that this is going to be in saturated condition. Now, here W into G equal to E into SR. This is the relationship, famous relationship, where W is given to me as 0.45 and G is given as 2.65 equal to E naught multiplied by, for fully saturated, the degree of saturation will be unity. Therefore, the value of E naught can be calculated. So let us calculate this. It is 0.45 multiplied by 2.65. 1.192. 1.192. So the initial void ratio before embankment loading has been calculated. So E naught is known to us. The value of Cc is given to me. Now, to compute this submerged unit weight, gamma prime will be gamma saturated minus unit weight of water, and unit weight of water is given over here. So what is the saturated unit weight? Gamma sat will be G plus E gamma W divided by 1 plus E. So G is 2.65 for the clay and E value is 1.192 multiplied by gamma W, that is 9.81 divided by 1 plus E becomes 2.192. So if you calculate the value of gamma sat, this becomes, let us calculate it, 1.192 plus 2.65, 9.81 equal to divided by 2.192. This gives you 17.196 kilonewton per cubic meter. So if you gamma sat you have calculated and gamma W is already given over here. So minus 9.81 is 7.38. So gamma prime becomes 7.38 kilonewton per cubic meter. So here in this equation now, it is very simple now. Up to 2 meter, it is above the water table. So the unit weight is 18.5 plus 4 into gamma prime just calculated as 7.38 equal to, so sigma naught prime will be 7.38 multiplied by 4 plus 2 into 18.5. 66.54. Therefore, sigma naught prime, the effective overburden pressure is 66.54 kilopascal. So, having got this value, now everything is known to us. H is 8 meter, that is the thickness of the clay stratum. Cc is given to you as 0.25. So, therefore, now it is very simple. This you have already calculated as 66.54. This is already known to you, given in the problem as 180 kilopascal. So, and E naught is also known to you. You have calculated E naught as 1.192. So, if you substitute and calculate, you will be able to get the value of SC. So, SC equal to 0.25 divided by 2.192 multiplied by H is 8 meter, log of 180 divided by 66.54 to the base 10. The answer will be in meter. So if we calculate, let us calculate and find out the answer. Log of 180 divided by 66.54 multiplied by 8 multiplied by 0.25 and divided by 2.192 is 0.394 meter. So the answer that calculate the primary consolidation settlement of the clay is the answer of this particular problem. So friends, we can take up the next problem, which is popularly asked in the GATE examination, and you should know it well. So the next question is going to be of 2021 set 2. So another problem we'll see. Problem looks like this. There is also set 2, the another problem. A clay layer has effective overburden pressure. P for pressure, O for overburden, prime means effective. Has effective overburden pressure less than PC. PC is pre-consolidation pressure. So pre-consolidation pressure is more compared to the present effective overburden pressure is less than P naught prime plus delta P. That is, after application of the loading, at the middle point of the clay layer, the pressure that gets developed is delta P, additional pressure that comes due to additional loading, the loading which you apply over the clay layer. So this condition is given. So in the clay layer has this, it is given like this, the condition given in the problem, then the correct expression, then the correct expression to estimate consolidation settlement SC is, so let us see the solution of this problem. So you have a clay layer, and at the midpoint of the clay layer, middle of the clay layer, the total overburden pressure is known to you, and due to application of the loading, the increase in pressure is going to be delta. So total pressure becomes this one. So here this is given to you as P naught prime. So this is P naught prime, and due to the application of the loading, it is P naught prime plus delta P. So when you apply the additional loading, so if you see this condition, this is very important condition, given that the effective overburden pressure, effective overburden pressure is less than pre-consolidation pressure. So if you plot it log P on the x-axis and void ratio like this, what is given is the overburden pressure is less than PC. So the overburden pressure is given as P naught prime. So P naught prime is less than PC, and this is the pre-consolidation pressure, PC. And the present pressure is given to you after PC, the curve becomes a virgin curve and behaves like normally consolidated. So in this part, it is behaving like over consolidated clay, and then it behaves like virgin clay or normally consolidated clay. So this pressure is P naught prime plus delta P. So this condition is satisfied. P naught is less than PC, and PC is less than P naught prime plus delta sigma prime. Now, if you want to find out the consolidation settlement SC, now for this, there is a higher pressure. So it is going to be, and for over-consolidated clay, you should always use the swelling index or recompression index. So swelling index or recompression index, CS or CR, divided by 1 plus E naught into H for this part up to here. Between this band, we may call it over-consolidated clay part as behavior like 1, and this is 2. So for 1, it is CS divided by 1 plus E naught into H into log of. Now it is going to be higher pressure is PC divided by effective overburden pressure plus. Now for part 2, it is going to be now behaving like NC clay, NC clay, and this is behaving like over consolidated clay. So for this part plus, it will be CC divided by 1 plus E naught into H, the clay layer, H is the clay layer, into log of higher pressure is this. So higher pressure is P naught prime plus delta P divided by lower pressure is PC. So this becomes the answer. So here, this part you can fill it. So they have given 4 expressions. You know which expression is going to be the correct one. You will have to choose that. So swelling index or recompression index, you can write it CR also. Recompression index equal to swelling index. And E naught is the original void ratio of the ground, E naught. And H is the height of the clay layer. And PC is the pre-consolidation pressure. So this is the answer of this question. Now the next problem is of 2021 set 1. This is set 1. So you can see a lot of questions are being asked from consolidation part. The soil profile, the problem is like this. The soil profile is shown in figure. Below. Find over consolidation ratio. Find over consolidation ratio, OCR, at the midpoint of the clay layer, at the middle of the clay layer. The groundwater table in the past was at 10-meter depth. 10-meter depth from ground surface or ground level and rose to 5 meter 5 meter from ground level, 5 meter depth from GL. Normally, the water table fluctuates during monsoon. It comes up, and therefore, the groundwater, the effective stresses when it goes down is going to be higher, and when it comes up, it is going to be lower. So 5 meter from the ground level. The unit weight of water is 9.81 kilonewton per cubic meter. And the figure is like this. You have the ground surface, or ground level is shown here. And initially, it is sandy layer, so sand, and this sand layer is up to 15 meter. So up to, from here to here, up to 15 meter, it is the sand, and the unit weight of sand is given to you as 17.5 kilonewton per cubic meter, as shown in the figure. The present groundwater table is somewhere here. So this is the groundwater table, GWT. This groundwater table is at a depth of 5 meter from the ground surface, and the saturated unit weight is 18.5. So from 17.5 it becomes 18.5 kilonewton per meter cube. And then followed by you have a clay layer. So clay layer, the thickness of the clay layer is 8 meter. So this clay layer has the saturated unit weight as 17 kilonewton per cubic meter. You have to find out over consolidation ratio. So this is the problem that has been given over here. So what is the over consolidation ratio? You will have to find out. So over consolidation ratio is the pre-consolidation pressure divided by present effective overburden pressure. So in the past, what was the quantum of pressure that was applied here is to be calculated. So first calculate PC, the pre-consolidation pressure, because the water table in the past was at 10 meter. which has rose to 5 meter as shown over here, 5 meter. But in the past it was at 10 meter. So it was somewhere here in the past. So this was up to 10 meter. So water table was up to 10 meter. So PC will be Z was 10 meter water table. So above the water table, the unit weight is 17.5 for sandy layer. So water table was here up to 10 meter. So pre-consolidation pressure needs to be calculated, and then for the remaining 5 meter it was underwater. So it was underwater means it is remaining 5 meter of sand, it was under water. So submerged unit weight will be 18.5 saturated minus unit weight of water, which is given in this problem as 9.81 plus. You need to calculate where? You need to calculate at the middle of the clay layer. So at the middle of the clay layer for 4 meter, so plus 4, this is 4 meter, 8 meter total. So middle will be 4 meter multiplied by 17 is the saturated minus 9.81 kilopascal. So let us take our calculator and see the values. So this becomes 175 plus 17 minus 9.81. 247.21 kilopascal. This is pre-consolidation pressure when water table is at lower depth in the past. So in the past, pre-consolidation pressure was calculated. Now, the present water table is at 5 meters. So find out the value of present overburden pressure. So up to 5 meter, it is 17.5. And for remaining 10 meter, it is going to be 18.5 minus 9.81 plus 5 plus 10, 15 meter over, and for remaining 4 meter, it is 17 minus 9.81 kilopascal. So let us calculate. 5 multiplied by 7. 203.16. So 203.16 kilopascal. So substitute here. This you want to find out. So PC is 247.21 and this is 203.16. So you can find out 1.2168. 1.216. This is the over consolidation ratio. So therefore, you got the answer for over consolidation ratio equal to 1.216. So friends, we can do any problem conceptually. What is needed, how to find it out, and if you know it conceptually, there is no reason that why can't you solve the problem quite accurately. Next problem we will be taking. So this is also 2021 problem and it looks like this. You have a footing which is embedded into the ground in silty sand. So let us take a footing. This is the footing embedded into silty sand, and this is in the figure shown here. This is at 1.5 meter, the base of the footing. Here it is 1.5 meter, right? And then the intensity of loading over this footing is 200 kilopascal. So that's also given to you. And there is silty sand. So there is silty sand, and the dry unit weight gamma D is given to you as 15 kilonewton per cubic meter. And the groundwater table from the base, it is at 0.5 meter from here. This is the groundwater table. And further below 0.5 meter, you have got a clay layer. So you have got clay which is normally consolidated. So NC clay you have got here, and this depth of this clay layer is 1.5 meter, and G is given to you as 2.65. So specific gravity is known to us, and the compression index is 0.3, and gamma saturated, the saturated unit weight is 17 kilonewton per cubic meter. And then followed by, you have dense sand. And below the groundwater table, here gamma saturated for silty sand is given to you as 18 kilonewton per cubic meter. So everything has been given in the figure, and the footing size is 2 meter by 2 meter. So B equal to 2 meter. So size, it is a square footing. So size of footing is given 2 meter by 2 meter. And pressure at footing base is shown as 200 kilopascal. And considering 2:1, 2 vertical, 1 horizontal. Considering 2 vertical, 1 horizontal load distribution. So load 2:1 method of load distribution. Calculate primary consolidation settlement. Calculate primary consolidation settlement, SC. Take gamma W, unit weight of water equal to 10 kilonewton per cubic meter. Well, a simple problem. If you know it, you can find out the solution of this problem. I have solved good number of problems in my previous videos on this. Once again, I will show you the load distribution below the footing is shown to you, and always at the midpoint, at the middle of the clay layer, you should calculate. So load is going to be distributed as 2:1. This is vertical, this is horizontal. And this is the clay layer. So, you know the formulas, so many times we have written. For normally consolidated clay, Cc divided by 1 plus E naught into height of the or thickness of the clay stratum into log effective overburden pressure at the middle of the clay layer plus increase in pressure due to the loading divided by sigma naught prime. This is the formula for primary consolidation settlement. So this you will have to use it. Now Cc is already given. Now how will you find out the E naught value, initial overburden pressure, void ratio? So initial void ratio E into, now what is given over here is G. So G and gamma sat. So what is the relationship between gamma sat and G? That you know it. So gamma sat equal to G plus ESR. SR is 1. into gamma W divided by 1 plus E. Therefore, from this I can find out the E naught value. So 17 equal to 2.65 plus E into gamma W is to be taken as 10 divided by 1 plus E. Or if you simplify it, 17 plus 17E equal to 26.5 plus 10E. So, 7E equal to, we can calculate it, 9 So, therefore, E naught equal to 9.5. So, let's calculate. Divided by 7. 1.35 up to 2 decimal places. Up to 3 decimal places, it will be 1.357. So, I am calculating up to 2 decimal places. So, E naught is known to me. CC is already given. E naught I have calculated. H is known to be 1.5 meter. So, E naught is 1.35. CC is given as 0.3. H is 1.5 meter. Now, sigma naught prime, effective overburden pressure, where? At the middle of the clay layer. So, how much it will be? Above the water table, what is the distance? That you should know. So, this is 1.5 plus 0.5, that is 2 meter. The unit weight, it is going to be dry, so it is gamma D. So, up to 2 meter. Now, for the remaining 0.5 meter, it is going to be 18 minus 10 effectives. So, you will have to take the submerged unit weight, which will be equal to 8. So, I have taken 18 minus 10, that is 8. So, you have come up to this. Then, at the middle, it will be 1.5 divided by 2, that is 0.75 multiplied by gamma sat is given to you as 17 for the clay. So 17 minus 10, it becomes 7. So let's calculate. This becomes 30. So if you calculate, this is 8 half, that is 4, plus 39.25 kilopascal. So this I have calculated 39.25. Now I would like to calculate delta sigma prime at the midpoint. That is due to this intensity of loading at the base of the footing. So, what is the load at the middle? That what is the load divided by area at the middle of clay layer? So, load is 200 kilopascal multiplied by 2 into 2. That is the area of the footing. So, that is the total load divided by area at the middle layer is 2 vertical, 1 horizontal. So, what is the distance? There is going to be 0.51 meter, 1.75. So, at 1.75, it will be B plus, that is 2 meter, plus what is the below the base? The load is going to spread. So, it is going to be 1.75. So, add 1.75 and for area take square because it is a square footing. So, delta sigma prime becomes 800 divided by, so let's calculate 800 divided by 3.75 56.88 up to 2 decimal places kilopascal. So delta sigma prime I have calculated as 56.88, right, kilopascal. So I know everything. Therefore, now finally I can calculate, therefore, the primary consolidation settlement SC equal to 0.3. So I will calculate it. 0.3 into 1.5 into log of sigma naught prime is 39.25. Delta sigma prime is plus 56.88 divided by 39.25. Divided by 2.35. So I am getting this answer of SC. I have already written all the values here. So by simplifying this, I am getting 0.0744 meter. And this is the answer. Friends, all types of problems that is being asked on consolidation of soils, we have tried to solve it. And I'm pretty sure that if you have understood it conceptually, you can do any damn problem in the examination. So be clear about the theoretical aspect, and you can apply the right formulae, and substituting the values, you can always crack GATE examination with very high marks. So wishing you all the best, and I will continue it further. So the next video, I will be taking some division problems. Thank you very much.